For today's lesson, uh, we first make a review of what we tackled last meeting. So last meeting we learned again about what mean, median, and mode uh, are, and then we also learned about the um, standard deviation and range. Okay, so these are, and you had an assignment or like a quiz I gave you, and I was supposed to give. I promised an assignment, but I never got to send it. Especially when I prepared this lesson, so I thought that what you will be learning in standard deviation is applicable also to this lesson. So I might as well give one assignment for the previous and this one. Okay. Also, last meeting we had a discussion among each group about the data that you're supposed to gather, and there were two groups who were not ready during the time, and then I told them to be ready for today, but I hope I won't make you mad if I say that you don't need to report today, because I wanted to go through the group um, updates very fast because the lesson is quite confusing. So I wanted to spend more time on the lesson, and also this being a Saturday, I don't want to spend a lot of time on the monitor with my students, no? So you might also have your own plans. So on a Saturday night. So I will just go through each. I will review what I can remember for each group on what data they're supposed to gather. And then, because the next thing that you're going to do, I'm going to give a new assignment after this, no? Um, what's happening here actually is that we made a shortcut. So, it, well, the time is just not long enough for us to go through the usual process, because after we determine um, the title, finally we're supposed to break that down into sub problems. And then after breaking that down to sub problems, so we now have more or less more specific idea on what to look for, what data that we will need, because the problem is still actually very big. No? And so we skipped that, and then we just went to what data that we think we need. And during the discussion, we made some scoping. I told you that okay, you should just stop here. You should include, or you should include this, etc. So these are. I'm just going to breeze through what I think are needed. If this is not complete, you can put in more. But these are things that went to my mind. Um, for the Team IC, study on the effect of work from home setup on interior design in the context of work productivity during the pandemic. So you need data on the setup that is being used by professionals and the problems encountered, and then of course the perceived advantages. I wanted to know, for example, whether what they perceived is actually realized, because a lot of people might say, "Ah, this is better because of this and that," but then is it really? So that's a good thing to discover in a research like this. So basically, your data source is a survey among professionals. So you're supposed to already identify who these professionals are. And then I think that this is very doable, considering that you only need to do a survey, so you can do a Google form and then send it out by email, and then hopefully get enough data, enough responses. For the global Palawenyo architects, you were not able to report last time, so I'm just trying to put my thoughts here. Study on the determinants of the surviving small resto bars amidst the pandemic in the context of Puerto Princesa. So you need to know, of course, the resto bars. I forgot to write here the names of the establishments which should be included in the study, their physical setting, the relevant policies, um, because there might be policies that attracted the people, for example, policy on health, cleanliness, or even about sanitation. And then what are the services they offered, including the products that they offer, the food, and then you need to know the assessment of the patrons. So therefore, you can have a survey. Um, but I forgot to put here that you also need to do site visit and documentation, because you cannot talk about physical setting. Uh, and you also need to do interview with the um, owners to know about the services they offered and then their policies. Okay, so I'm sorry if it's not complete because I did this last when I prepared for this class, so I missed out a lot. So just please take note. For Asia architects, a study on the link of public perception in the architectural profession and the actual practice in the context of Puerto Princesa, Palawan. So you need the opinions of people. You have to qualify who these are on architecture profession, what they think about the architecture profession, about what they think about the architecture law, and what they think about the malpractices. Okay, so I remember that the one who presented gave a lot of things, but I mentioned that these are things that you should already know because these form part of the rationale. Okay, so data source can just be a survey among architects, engineers, and a lot of laymen. Um, Maybe you will qualify later what layman you need. People who are in the position to build houses or like that. No? So don't ask children or don't ask, I don't know. Well, basically, children, don't ask them. They're not going to build. Team EPSU was not also able to present. But then I decided to just write my thoughts here. A study on the determinants of students not using the drafting studios in the context of the College of Architecture and Allied Discipline of Eastern Visayas State University. So we need to know the physical setup. If there are changes, so the changes should be documented. Um, I don't know if part of your plan is to compare the old setup with the new one. If it is, then you should include the physical setup of the old one. Then behavioral patterns. Behavioral patterns meaning how did the students use the studio, okay? Um, and types of activities and requirements given by the teachers. Because for all you know, maybe the requirements did not require them, did not require them to use the table. So maybe they're asked to use the laptop or just the drawing or to do something else. That's why they ended up not doing the table. So things like this should be covered. Um, well, again, I forgot to put the site visit there and the documentation for the physical setup and observation for the behavioral patterns, but there should be a survey among the teachers and also the students who use the drafting studio. So do not include those who know nothing about the drafting studio. For Team Juke, the study on the consequence of retaining the 50-year-old asbestos acoustic insulation in the context of the Rizal Theater in Cagayan de Oro. So we need the physical setup and studies on mitigation measures. Okay, there are, I'm sure, I think you showed a lot of studies. on how this can be still be used as long as well there are conditions, okay, and then mitigation measures. So whether those conditions are applied. So you have to check, no? And then you also need to include the use of the facility, how often, how frequent, for what activities, etc., etc., and just see the relations later. So data source, the I think survey or even interviews with users, administrators, and experts. But I think this should be more on interviews, no, rather than survey. And then literary search for the studies, and of course site visit for the physical setup. Team MAR, a study on the link between cost efficiency and reduction of virus transmission in the context of wall claddings in response to the challenges of the pandemic in commercial interior design. So, as mentioned last time, we need to know what are the commercially available cladding per material that was mentioned. And then the cost impact of the cladding materials. So, this is not only the price, but the impact, meaning to say anything else that will add to the cost um, of handling. So it's like the footprint, no? The cost footprint of this material. For example, shipping, if it's not available locally, you have to get it from abroad. So for including the labor that are required to install these finishes, yes, this cladding materials. So they might be more expensive. So they're part of the study. Properties of cladding material, because you're going to compare it with when you assess it. So it depends on the criteria for assessing. So what properties you need to gather. So you'll be doing a lot of literature search because I don't think you can go around for this. Then survey hardware owners, okay, um, to ask them about this data. And you might need to be uh, very tactful about this, no? Because normally when um, hardware owners are asked so many questions about products, and especially if they know that you're not buying anyway, so they might not entertain you. But you have to make sure that they know that this is a study. Dear Charmander, a study on the effect of easing the physical distancing in public transportation on travel efficiency in the context of the COVID-19 situation in the Philippines. Um, so we need opinions. So this is basically just opinion-based study, no? On the different distances proposed for physical distancing, and then opinion on the spread of COVID-19. So you need to interview commuters and drivers. And last time I mentioned that it should only be for the jeepneys and buses because the taxis do not, the motorcycles do not apply. And Green City Architects, a study on the relationship between the plants used in urban parks and their local environmental condition in the context of the rehabilitation of urban parks in Puerto Princesa. So you need to know the existing parks, the existing plants used. Also, you record the microclimate, basically the environmental condition, how long during the year is it hot or cold or rainy, etc. The soil condition, whether they're good for plants, etc. Um, and included in the environmental condition will be the neighborhood, okay, because the pollution is another aspect of that may affect the life of plants. Data source, of course, site visit, identification, and sampling, and of course, you do a lot of literature search on the types of plants that you'll be assessing. Okay, I think that's it, no? So basically, your next step is to make the survey forms. Um, well, not only the survey forms, but the research tools. If you're supposed to interview, so the interview questions. If you're supposed to do survey, so the survey forms. And then if you're supposed to go site visit, so the checklist. So those are the things that I will need from you. Okay. So I will review again what I just mentioned during this week, and then I will, because I missed out a lot of things. So I try to recall them and then send each group a message about what I expected from them. Okay, for example, if for one group, if I expect only survey forms, another group, if I expect all three of them, etc. No? So that's your assignment for this week. Okay, so far questions? No questions? Okay, so there's one absent. I wonder who. Two, because I'm included in the count. There are 23. Anyways, so let's go to quantitative analysis. This is part two on inferential statistics. To replace the lecture I gave last Saturday about inferential statistics, because I realized that there were some things that I missed, and then there were also some things which were not presented properly because they were not in a very orderly manner. No? They were not presented in a very orderly manner. So we again define population, which is the group of individuals or items to be studied. And then we also mentioned there that the population is normally too big to be studied. It's almost impossible to account for each one. That's why we need to get only a sampling. So a sample, which is that population measured, which is measured or observed. And then from this sample, which is now manageable, so we try to make a judgment, and that's what we call inference. We infer a conclusion, we make a conclusion, and then hopefully um, that conclusion is something that we can confidently say would represent the rest of the population. So this exercise can only be true if the sample is representative of the population. And even then, the sample is very unlikely to reflect the population exactly in all respects. Okay, so since there is uncertainty as to how well the sample results reflect the population, statistical methods have been developed to reduce the quantity and quantify this uncertainty. Okay, because things are not always perfect, so we have to find a way to still come up with something which is acceptable. And then there are two aspects of statistical inference. One is estimation, the other one is hypothesis testing or using statistical tests. And this lecture is about the first one, which is estimation. To obtain an accurate estimate of a population parameter, the sample must be representative of the population. So that's what we've been saying earlier. So we're trying to avoid bias, which is that aspect of where we lean towards one particular side in terms of maybe population. We lean on one particular aspect of the population. For example, if the population is just majority female, so it's like bias to all female. So the item should be selected from the population at random. So this means that all members of the population have an equal chance of being in the sample. So the precision of the estimate depends on the size of the sample. So the larger the size of the sample, so the more precise the estimate. Okay. Precision is measured by calculating the standard error of the estimate or a confidence interval, usually the 95% confidence interval. So confidence interval, which we will define in the next slide, has something to do with the range, no? Where we can say that we are confident that the answer is between this lower range and an upper range. Confidence intervals are often used with a margin of error. Therefore, we can say it tells you how confident you can be that the result from a poll or survey reflects what you would expect to find if it were possible to survey the entire population. So confidence intervals are intrinsically connected to confidence levels. We mentioned earlier that the confidence level is something like 95%, and normally this is the standard. If in a problem, statistical problem, the confidence level is not mentioned, you can assume a 95 confidence level. So this graph shows basically the concepts that we have been discussing so far. So you have a graph of a standard deviation, and then this is the normal distribution. It forms a bell curve, and then 1 minus alpha is the confidence interval. Okay, that means that there are parts of the distribution where you are no longer uh, confident that this will still fall under the result when this test is done again. Okay, um, so that part which is red is called alpha, and since they are distributed in two sides or two tails, one in the left and the other right, that's why it is stated there as alpha over 2. So it's divided into two. And so therefore, if 1 represents the entirety of the distribution, so you deduct alpha, and then you get your confidence interval. There are two particular groups of formula that we can use in terms of getting the confidence interval. One is for a population mean, the other one is for a population proportion. We will talk first about population mean. So the confidence interval for a population mean is expressed as x bar minus EBM and x bar plus EBM. So this is the range. So the lower range is x bar minus EBM, and the upper range is x bar plus EBM. EBM is the error bound to for the mean. No? This is your margin of error, and x bar is your standard mean or sample mean. Okay. So the confidence level is the area under the curve in which we expect the population mean to be located in. So this is what we mentioned earlier as the 1 minus alpha. Basically, the formula to get the um, confidence interval varies depending on two factors. Um, After we get the sample mean, x bar, we identify whether the population standard deviation, which is represented by sigma, is known or unknown, and then whether it is estimated by the sample standard deviation, okay, which is represented by S. So if the population standard deviation is known, then the appropriate value from the standard normal distribution, Z value, is used. Okay, the symbol I used here is Z with the asterisk. In some books in statistics, they call this Z alpha or simply Z. Okay, for our purposes, I will just call it Z since it is cumbersome to say Z asterisk. So to get the confidence interval, you have to look for X bar plus and minus the EBM. EBM or the error bound for the means is actually Z times the standard error. And the standard error is actually sigma over the square root of n, where n is the sample, okay, the number of samples or sample size. So therefore, our formula for confidence interval is x bar plus and minus z times sigma over square root of n, or the sample mean plus and minus the z value times the standard deviation over the square root of the sample size. If the population standard deviation is unknown, then the student t distribution is used as the critical value. This also applies when you have one small set of data, less than 30 items. So therefore, the formula for the confidence interval is x bar plus and minus the error bound for the mean, where error bound for the mean this time is actually equivalent to t times the standard error, or the standard, since the standard of error is the sample standard deviation over the square root of n sample size. Therefore, our formula for the confidence interval is x bar plus minus t value times s over square root of n. Okay, so or the sample mean plus and minus the t value times the sample standard uh, sample standard deviation over the square root of the sample size. So after finding the all the um, values, so you now have to plug in the values to the appropriate equations to get the confidence interval, which is expressed as CI is equal to x bar minus EBM and x bar plus EBM. So we can more appreciate this by going into sample problems. No? First sample problem, consider the following times at the nearest hour that 16 patients experience relief from a migraine after taking a certain drug. So the values, there are 16 values, 7, 8, 1, 2, 6, 3, 5, 2, 4, 9, 4, 6, 5, 6, 9, 8. Okay. So note that the population standard deviation sigma is unknown. Therefore, the t-distribution value will be used. So this is the first test that you will conduct to know which formula you're going to use, whether you're going to use the t-value or the z-value. The sample standard deviation S will be derived first. To get the standard deviation, we first solve for the means or the x bar, which is the summation of all the samples over the number of samples. So in which case the summation, if you add up all of these numbers here, you get 85, and then we have 16 samples, so you divide 85 by 16 and we get 5.312. So this is the estimate of the mean time for a patient to experience relief is 5.312 hours. So that means when you give the drug, it takes 5.312 hours an average for the drug to take effect among migraine patients. Okay. To solve for the sample standard deviation, the formula is the square root of the summation of xi, or summation of the difference between the sample minus the mean squared, all over sample size minus 1. Okay. And here we conveniently computed that to be 2.522 hours. You can do that manually in calculator since the formula is here. Um, the note that the t-value, to find the t-value, we need two variables, the alpha level and the degree of freedom. Okay. The degree of freedom is actually represented by the letter V, small letter v. So the alpha level may be derived using the equation 1 minus CL over 2, okay, all over 2. So CL being the confidence level. So since we know the confidence level, which is 95%, so we deduct that from 1, we get, and then divide that by 2, and so we get our alpha level of 0.025. And then for the degree of freedom, the formula is n minus 1, or the sample minus 1. Our sample is 16, we deduct 1, so it's 15. And then with these two values, we look up a table to get the uh, t value. So this is the table, and along here, along the columns, we see our alpha 0.025, and along the rows we see our degree of freedom. We look for 15, and then they all point to this value, which is 2.13145. So that's our t value. So we now plug in the values of the mean, of the t-value, the standard deviation. Of course, you already know the sample size. So the mean is 5.312 plus and minus the t-value, which is 2.13145, times the standard deviation, which is 2.522 over square root of the sample size, which is 16. And after computing everything, we get the answer, which is 1.3438792225. Now, this answer we add and we subtract to our mean, which is 5.312, to get the confidence interval. So the lower range is now 3.968120775, and then the upper range is 6.688979225. So what does this mean? So this means that we are 95% confident that if the test were conducted again, the number of hours that patients will experience relief from a migraine after taking a certain drug will be between 4 to 7 hours. So this is rounded off. Three, instead of 3.96, so it's 4 hours. Instead of 6.68 hours, so it's 7 hours. Sample problem number 2. A group of 10-foot surgeon or surgery patients had a mean weight of 240 pounds. So the sample standard deviation is 25 pounds. Find a confidence interval for a sample for the true mean weight of all the foot surgery patients. Find a 90% confidence interval. Okay, so the sample standard deviation is given. It is 25 pounds. And then the mean weight, X bar, is also given. It is 240 pounds. So since only the sample standard deviation is given, so the t-value again will be used. The t-value will be determined next. So we said that the t-value needs two variables. The first is the alpha, the second is the degree of freedom. So alpha is computed as 1 minus CL over 2. Confidence level is 95%, so 1 minus 95% over 2 gives us 0.025. And then for the degree of freedom, it is n minus 1, or the sample size minus 1. Our sample size is 10, I'm sorry. And then we deduct 1, we get the degree of freedom, which is 9. Okay, so then having 0.025 as alpha and 9 as degree of freedom, we look up the value of t in this table, and then we find 2.262157. Okay, so we then use all the values, we plug it in into the formula, um, and we get the result, which is 17.882 or 883. So we, to get the lower end of the range and the upper end of the range, we deduct or add this to the confidence, to the means. No? Therefore, we have a confidence interval of 222.115 and 257.883. So what does this mean? So we are 95 confident that if the test was conducted again, the true mean weight of all foot surgery patients will be between 222 pounds to 258 pounds. So that's what it means. Okay. A third sample, the problem says construct a 95% confidence interval. An experiment that found the sample mean temperature for a certain city in August was 101.82 degrees, no? With the population standard deviation of 1.2. There were 6 samples in this experiment. So the population standard deviation is given, not the sample standard deviation. So it is given to be 1.2. The mean is also given, it is 101.82. So since the population standard deviation is given, the Z value will be used even if the sample size is less than 30. So the sample size is not the really important condition when to use a t value or z value. So it is whether you're using a population standard deviation or simple a sample standard deviation. So to find the z value, the area to the left of the curve is determined, and this value looked up at the z table. So to solve for z value, we get the area to the left of the curve. And the formula to get that is the confidence level plus 1 all over 2. Okay, so our confidence level is 95%. So we express that in decimal 0.95 plus 1, and then the sum we divide by 2, and we get 0.975. So looking up for the z value in a z table is different from the t table because the process is reversed. So we look first for so this is the z table. We look for first for the value inside the table, and when we go up and to the side to look for the values along the column and along the rows. So here along the row we have 1.9, and along the column headers we see 0.06. We add those two values, we get 1.96. Therefore our z value is 1.96. Okay, so again, we plug in the numbers into the formula. The formula is z bar plus and minus z value times the standard population standard deviation over the square root of the sample size. Okay, when we compute that, we come up with the answer 0.96. So we deduct 0.96 from the means to get the lower end of the range, and we add it to the means to get the upper end of the range. So our confidence interval now is 100.86 and 102.78. So therefore, what this means is that we are 95% confident that if the test was conducted again, the mean temperature for a certain city in August will be between 100.86 to 102.78. Okay, so the other set of formula that I mentioned has to do whether we are dealing with population proportion. The first one was population mean. Okay, so this time we have a population and we want to know the percentage, how the percentage characteristics of the population. So the object is to estimate a population proportion using a sample population represented by p hat. Okay, the caret on top of the p is the symbol, and it is mentioned as p hat. No? Plus or minus a margin of error. This time it's EBP. It stands for error bound for the population, so not for the mean. The result is called a confidence interval for the population proportion. And the formula is p hat plus and minus z value, and then the square root of the product of p hat times 1 minus p hat all over n. Okay, and then the confidence level interval for a population proportion is expressed as p hat minus ABP and p hat plus ABP. So you see here at the sides um, the description for each of the variables that we mentioned. So we now look for the sample proportion p hat, and p hat is simply um, x over n, x being the sample, and then n is the population. Okay, um, determine the confidence level and find the appropriate value. So you plug the found values into the appropriate equation to get the CI, which is expressed as this one. So these are the formulas. And then it's best to solve a problem to understand how the formula is used. So sample problem number 4, calculate a 95% confidence interval for the true population proportion using the following data. So the number of trials is 160 and the number of events is 24. So to solve for the population proportion, we look for the p hat first. P hat is equal to the number of events all over number of trials. We get 0.15. And then next we solve for the z value. To get the z value, we need to get the area to the left of the curve, which is CL plus 1 over 2. Our CL is 0.95 plus, and then plus 1, then divided by 2, and so we get 0.975. And so we look for the value here in this table, and we got 1.96. So we then plug the numbers into the formula and solve for the confidence interval. Okay, after putting in the confidence interval, the numbers, we get a value of 0.0553, which we deduct from the p hat to get the lower end of the range, and then we add to the p hat to get the upper end of the range. Thus, our CI is 0.0947 and 0.2053. Okay. So another problem, suppose you want to estimate the percentage of times with 95% confidence. You're expected to get a red light at a certain intersection. Suppose you take a random sample of 100 different trips through this intersection and you find that a red light was hit 53 times. So the red light was hit 53 out of 100 times, so the p hat is equal to 53 over 100, which is equal to 0.53. And then this is the alternate way of looking for the z value. We only identify our CL, our confidence level, and it's 95. We look for it in this table, and then we get the z value automatically to be 1.96. And so we plug in all the numbers in this formula, and we get 0.002491, which for the EBP, which we will add and subtract to the p hat to get our upper and lower range. Thus, after doing all the computation, we get a range of 43% to 63%. So it says here that to interpret these results within the context of the problem, you can say that with 90% confidence, the percentage of the times you should expect to hit a red light at this intersection is somewhere between 43% and 63% based on the sample. To summarize, these are the formulas that we've been using. So there are two groups of formulas: confidence intervals for population mean and confidence interval for the population proportion. Now, for the confidence interval for the population mean, there are two variations depending on whether the population standard deviation is given or whether only a sample deviation is given. Also important is that the sample size is 30 if only the sample standard deviation is given. The other type, which I mentioned earlier, in statistical inference is the statistical test or the hypothesis. I mentioned that we will be talking about this until the end of the semester, starting next week. Okay, why? Because of this, there are two types, by difference and by association, and for each type, you have it depends. The statistical test depends on what type of data you have, whether it's nominal, ordinal, or interval, and whether there are two samples only or more than two samples, and for each, whether it's independent, the samples are independent or paired. So depending on the condition, you have here all the types of statistics that you have to learn and that we should apply. Okay, some of your jaws may be dropping right now, but don't worry, you'll survive. No? And by association, again, the type of data that you have, whether nominal, ordinal, and interval, and the type of statistics that should be applied. So we're going to discuss as many as we can on these ones here, and these ones here. I think some of them are double. Chi squared is here. Um, Spearman is on the other side only, and Pearson is on the other side only. So that no, we're not going to tackle all of this, but only the more popular ones. In fact, the first that we will tackle is the chi squared. So welcome to statistics. Okay, so that's why please be patient. Just in case you have some questions, like for example, when we talk about standard deviation, some of you might be asking, so what good is this standard deviation for me? Okay, and then today we learned that the standard deviation, the curve, is very important uh, when we are trying to learn about the confidence level by when we are doing some estimates. No, um, so, and then of course, the standard deviation is important in the equations, and even the means is very important. No? So, we'll do these baby steps. So, until you finally uh, get the hang of using statistics. Um, Therefore, the use of statistics really is like um, just to present or just to appease the the people know that the research is really valid. Okay, now we are used to not presenting statistics because most of the time we deal with like authority, the logical argumentation, um, and then actually it's wrong to say that we cannot apply that statistics, this type of statistics is not applicable to our studies. No, because whatever we have done, our own thesis probably before in in college, and even the one that you're doing now, you have to apply this to tell the people that you are so much percentage sure that the answer is correct. No, and it's between this level to that level. So that's simply uh, the use. Um, so maybe I'll end with that. No, hopefully it gets digested during the week. I will post a assignment on Monday. I'll have to write them down tomorrow, so that you can do some um, practice, and then so that the questions will also come out just in case you cannot ask question today because you're so confused. um, but actually the operations that we did, mathematical operations, were quite simple. It's just that there are too many variables, but after a while you get to familiarize yourselves with it. Because, for example, we've been talking about mean and mean and mean, then it's just like, okay, instead of calling it mean, let's call it x bar, like that. So we've been talking about standard deviation, so instead of calling it standard deviation, let's call it sigma. So it's like that, no? So it's just a frame of mind. Very good. So if you don't have questions, do you have questions? Let's end na. Gutom na. So wala na questions, no? So I'll just stop the recording.